So this question is going to be looking at momentum. So starting off, some quantities are scalars, some are vectors. So which of the following quantities are scalars? And importantly, it says tick 2 boxes. So I'll look at the scalar quantities. And so displacement, well, that's going to be a vector. Distance is going to be a scalar. Force is a vector. Speed is a scalar. Velocity is a vector. So my ticks are going to go into that one and into that one. Now, if we quantify, what does scalar mean? Well, scalar is magnitude only, whereas vector quantity is magnitude and direction. Okay, so what is the difference between the vector and the scalar quantity? So if you know that, that's that answer. I'm not going to write it again, but then go into there. Okay, so this is our scenario which is going to link into momentum. So we've got bumper cars. Bumper cars are at a fairground ride designed to bump into each other. Now the diagram shows two bumper cars moving towards each other, which is shown by the arrows. The momentum of each bumper car is shown by the arrow. So the arrow is really important for the next question after this one. So if you look at, give two factors that affect the momentum of each car. Well, momentum, so I'm going to write this, momentum is equal to the mass times the velocity, or P equals mv. So if you're looking at momentum, well, mass is going to be a factor, the mass of each moving vehicle, in this case the bumper cars, and then how fast they're going, so velocity would be another one. Now momentum is a property of all moving objects. Okay, so we've got two moving objects, and to get this moving, well, it's going to need a motor, and for a motor it's going to need power. So power of the motor, and this one here also, well, friction, because you're going to get you know, from the bumper car, when it's moving, friction is going to be produced. Okay, so two of them answers would have given you 2 marks. Okay, so we've got a 4-mark question, and it's applying the law of conservation. Okay, so what I'm going to do, I'm going to kind of go through the teaching steps, break it down, and then we'll put the answer in. So we need to remember that in this scenario we've got a conservation of momentum before the collision, and we can say that is equal to the conservation of momentum after the collision. So, you know, it poses the question, well, what does this mean in terms of this question? So what does this mean, okay, in terms of the question? So if I draw a ruler, the two bumper cars at the time of the collision. Sorry about the drawing, do the job. Okay, so there's one cart, and then I've got another cart which there. Okay, now if we talk about this bit here after, so after the collision, now the cars are no longer going to be moving, okay? So what we can say is, after the collision, the total momentum is equal to 0. I'm going to underline that because that's important, because they are stationary. Stationary, like so. Okay, so if it's after, what we're saying is it's 0, and if we're talking about the law of conservation, well, if it's 0 at this point and it's equal, well, it must have been 0 before the collision. So before the collision, total momentum was also 0. Now we need to talk about the y, so I'm going to do another drawing, running out of space, so I'll push that up. Now these need to be a little bit apart before the collision. Okay, I get the idea. And then I'm going to measure an equal magnitude. So I'm going to go 3 centimetres in that direction. 1, 2, 3 in that direction. So what I've drawn there is I've replicated that. So you've got the momentum. I've drawn my arrows. And my 2 arrows are equal in magnitude, and they're also opposite in direction. And this is the reason why it's 0. So to finish off, we can say it is 0 because magnitude is the same. That's the same size because the magnitude demonstrated by the arrow, and the direction is opposite. So they cancel each other out. It's opposite. So, and then momentum is conserved. Okay. So I'm going to leave it at that. So if I was going to write this down, in terms of my answer, I would make a reference to this. That would be 1 mark. Okay, and I wouldn't need to do the drawings, but in terms, that'd be my 1 mark there. My second mark is the after the collision and making reference to the 0. So that'd be 2 marks there. That'd be my second mark, sorry. And then so before the collision, the total momentum was also 0, so that's my third mark. And then my fourth mark is talking about this direction is opposite. Sorry, the direction is opposite and equal in magnitude, because I put the same there, and that would be my fourth mark.